The first two properties, commutative and associative, are properties that you're probably familiar with from high school. The third property that I'm going to talk about, the well-defined property, is probably one that you never saw defined in high school, even though it's one that you did use. Its definition is going to be a little more complicated, and we will state it now. So our third property is the well-defined property. It's defined like this. Again, suppose that both S is a set and star is an operation. We say that star is well defined on S. And well defined is hyphenated. And this means for all four elements A, B, Y, Z, if both A equals Y and B equals Z, then if both A equals Y and B equals Z, then A star B equals Y star Z. Now, you should think of well-defined, the definition is a way of saying that an operation is internally consistent. If you combine equals with equals, you should end up getting equal things. In other words, what this is saying is there is only one possible value that A star B can be. It's not possible to get two different values for A star B. Now, all throughout high school, you took for granted that all four familiar operations were well defined. So we had the following well-defined axioms, which we took for granted. We had that addition was well-defined on R. And this meant that for every A, B, Y, Z in R, every A, B, Y, Z in the set of reals, if both A equals Y and B equals Z, then A plus B equals Y plus C. And similarly, we had for the other three operations were also well defined. So we had subtraction was well defined on R. If A equals Y and B equals Z, then A minus B equals Y minus B. We had the multiplication was well defined on R. We should actually say is well defined on R. If both A equals Y and B equals Z, then A times B equals Y times Z. and division is well defined on R. If both A equals Y and B equals Z, then A divided by B equals Y divided by Z. Now, it's important to talk a little bit in the definition of division here about dividing by 0. You could say, well, 1 equals 1 and 0 equals 0, so A and Y are 1, B and Z are 0. Does 1 divided by 0 equal 1 divided by 0? Well, they're both undefined. They're not really not equal to each other because they're not defined. They're not really are equal to each other either because they're not defined. So this is a tricky thing. The way we get around this is we say that A star B equals Y star Z, provided, with the caveat here, provided that either of these two expressions are defined. This means division is still well defined, even though division is not always defined. Dividing by 0, for example, is not defined, but division is well defined because you can't divide two numbers and get two different things. Being well defined just means you can't get two different things when you do an operation. Now, where you have actually seen well defined in your high school algebra class. For example, if I told you the sum of two numbers is 10, the difference is 4, what are the numbers? Take this typical problem from high school algebra 2, for example. The sum of two numbers is 10. The difference of two numbers is 4. What are the numbers? Well, I could write these as two equations here. I could write these as m plus n equals 10 and m minus n equals 4. Now, the easiest way to solve this would be to add the two equations together. So when I add the left-hand side together, I'm going to get 2m. Notice the ends cancel. When I add the right side together, I'm going to get 14. So 2m equals 14. Thus, m equals 7. And n equals 3. Now, let's go back and look at this step here. How did I get from here to there? Well, I added the two equations together. Why is this legal to add the two equations together? Well, pretend this m plus n is A and the 10 is Y. The m minus n is B and the 4 is Z. So A, B, Y, Z. We have that A equals Y. We have that B equals Z. And the fact that addition is well defined says that A plus B equals Y plus Z. Or in other words, that 2m equals 14. Essentially what well defined says is that you can combine equals to equals and get equals. You can add equals to equals and get equals. You can subtract equals from equals and get equals. You can multiply equals and equals to get equals. And you can divide equals by equals and get equals, provided that your division is defined. Okay,